Hi, this is Kshitija Pokle.
Hello, this is Neha Bedgeri.
Hi, this is Shangraf Raina, and in this video we'll be demonstrating our final data mining project, that is predictive modeling to identify opioids prescribers. So in this slide we'll be discussing the contents of a presentation. To start with will be the introduction, that is regarding the opioid overuse and the statistics related to opioid overuse. Then we'll be discussing the data set that we have used in our predictive model. Then in the visualization we have used Tableau to basically provide certain insightful information. Then we'll be discussing our problem statements. There are two problem statements then we'll be discussing the pre-processing that we have performed using SANS Enterprise Miner. Then here we will be providing the result of our predictive model. Then in the conclusion we'll be interpreting the results of a predictive model, and in applications we'll be providing the real-time integration of a predictive model into the real world and how it can help the US. So the basic motivation behind choosing this data set was the increase in the fatalities due to drug overdose in the United States of America. So opioid is basically a class of drug that basically include heroin and certain pain relieving drugs like oxycodone and hydrocodone. So these opioids basically attack the nervous system of a human and basically results in the provision of pleasurable effects and gives a sensation of relieving pain. Some statistics related to opioid overdose that we came across were like in 2014 around 47,055 accidental deaths were observed in the United States of America, which is quite a huge number. Then also of the 21.5 million Americans of the age 12 or older had a problem of substance use disorder in 2014. Also, it is observed that 23% of the individuals who use heroin develop the problem of opioid addiction. Now we'll be discussing the data sets. So the first data set on which we actually performed our predictive modeling was that is US opiate prescription data set. It had 25,000 rows and 256 columns. So the columns were like NPI, that was a unique national provider identifier number which we took as an ID in SAS Enterprise Miner. Then we had gender, then we had state, that is a US state by abbreviation. Then we had the credentials. Credentials are basically indicative of a medical degree of the prescriber. Then specialty. Specialty means the type of medicinal practice the prescriber is into. Then as you can see here, there are certain columns which are marked in a pale yellow color. These were basically total 255 columns, which were the combination of opiate and non-opiate drugs having numerical values of prescriptions. Then the final one is the opioid.prescriber, which is our Boolean target variable and which basically provide the information of whether the individual prescribed opiate drug was prescribed more than 10 times a year or not. If it was prescribed, then it was 1. If not, then it was 0. So the next data set was a drug overdose data set having 4 columns. It had the details of state, the population of the state, the number of deaths that occurred in the state due to drug overuse, and then it was the abbreviation of the state. Then the third data set was the opioids drug data set, which basically had the detail of all the opioids drug. And so coming to the visualization, so here we actually did a data exploration and came across certain good and insightful facts. So as you can see on the left, we got to know that the prescribers having the credential of MD degree tend to give more opioid drugs, you can see here, as compared to the others. Then on the right side you can see that CA, California, has the maximum number of ones, that is maximum number of opioid prescribers as compared to any other state. So we also got to know that California, having the maximum opioid prescribers, it also had the maximum number of deaths, which was around 4,521, and due to drug overdose, and also opioid prescribers in total being 2,562. Now we also came across certain information which actually resulted into performing pre-processing. So the first one being, like, we found in Tableau that for the specialty column in our main prescription data set, many of the values had very few instances. Like homeopathy contained only one row, that is one row out of 25,000. So we actually have fixed this issue by clubbing them together into another column using SAS Enterprise Miner, which we'll be discussing later. And then the other thing that we came across in Tableau was when we compared the two files, that is the drug overdose file and the prescription dataset file, we got to know that there were 5 state abbreviations that were missing in the overdose file. So we actually checked on Google that whether these states were legit or not, and after verifying that, we observed that they also had a very few count, and the count was between 1 to 3 instances in total for 25,000 rows. So we did the same for this as well through SAS Enterprise Miner. Now we come to our problem statement 1, which is to predict likely prescribers of opioid based on drug prescribed count. Here you can see that we have used three models. One is the decision tree, other is the neural network, and the third one is the gradient boosting. So in file import, we actually imported the file and chose a target variable, which was opioid.prescriber. And the data partition that we actually took was 60-20-20. And we actually took that by actually performing a series of tests, and 60-20-20 provided us the best results here. Now comes the pre-processing part. Came across that the credentials column had 763 missing values. So in order to impute these values, we actually used an impute component in SAS Enterprise Miner, and on the left side in the properties we took input method and with unique values, and we chose count method since it was a nominal variable. And as you can see, MD was the value that was imputed. Now the next pre-processing was the specialty and states having some rare instances. So for that, to deal with that, I actually used the transform variable component in the SAS Enterprise Miner tool, and which basically groups the rare levels. And here I have chosen the method to group rare levels, and it will be given a name of underscore others underscore. And for that, I have chosen a cutoff level of 0.0013, which basically means that any value less than 0.0013 will be referred to as rare and will be grouped. And as a result, we came across 5 rare state groups and 59 rare distinct specialities. And this was the transformation statistics once the transform variable was applied. Once we executed a model, through model comparison, we got this result. We saw that decision tree with an accuracy of 93 and misclassification rate of 0.07 was the winner here. And we also have provided a snapshot of the classification table of the decision tree. And as you can see, all the false positive, false negative, true negative, and true positive details are provided here for the training and validation data. And you can as compared to neural network and gradient boosting, these values were very significant. And so this was the decision tree that was created. It in total had 9 leaf nodes, and as you can see, all the split is made on the opiate drug columns, and then a split was made on the specialty. And you can see, as per the color in SASE Miner, more darker the color, more better is the split. So all these splits had 90 to 100% ones here, that is opiate prescribers to this decision tree, and it performed really well. And as you can see, the first split was made on hydrocodone acetaminophen. The same detail is provided in the output window of decision tree in the variable importance tab. You can see hydrocodone acetaminophen had a variable importance of 1, and hence the first split was made on it. So it was the most important variable. Now, when the inference that we actually came across on the first problem was that we made a prediction based on obvious opioid drug prescription count. So we created a second problem statement in which we actually removed all the opioid drug columns and kept only non-opioid drugs column in our data set. And now we actually thought of making predictions based on the prescriber specialty and the prescription rates on non-opioid drugs. So for this, to start with, what we did was in the file import, we rejected all the opioid drugs and marked it to rejected here, as you can see. So here comes the problem statement number 2, which is to predict the opiate prescribers based on specialty and non-opiate drug prescribing behavior. And the 3 models that we have used are decision tree, gradient boosting, and neural network. And again, for data partition, we have used 60-20-20 combination because it was providing us the best results. Rest all pre-processing was same as problem statement 1. When we executed this whole model here, as you can see, decision tree with an accuracy of 80.9 to perform better. And we also checked the classification table of decision tree and compared it with the neural network and gradient boosting, and we found out that decision tree had better false positives and false negatives values, which were pretty less than that of neural network and gradient boosting. And also the true negative and true positives are much more. So this was a decision tree that was created of max depth. So the first split basically here was made on the transform specialty. Same can be observed in the variable importance. Okay, so now basically the conclusions that we have received, that we basically can infer from the results of the predictive models for both the problem statement 1 and 2 will be discussed here. So we see that decision tree performed the best for both the problem statements, also provided us results pretty faster as compared to gradient boosting and neural networks. Then For problem statement 1, we see that hydrocodone acetaminophen was the most prescribed opiate drug in case of predicted opiate prescribers. And for problem statement 2, the prescribers with the specialties like internal medicine, family practice, hematology, oncology, and urology were prescribing the non-opiate drugs of gabapentin are more likely to be opiate prescribers. So now coming to the application part, that is integrating a predictive model to the real world. This model can be used by the hospitals which have the chain spread across the United States of America to find the potential prescribers of opioid, which will definitely help to reduce the fatalities or the accidental deaths due to the opioid overuse. Then also US government can track the prescription of opiate drug like hydrocodone acetaminophen, which had the maximum opioid prescribers. As I mentioned, it will definitely help in decreasing the death count. And whereas usage of this model can be by making it available online, where common people or the patients can use the results of this model and get aware of the fact and the type of doctors who are prescribing the drugs with opioids, so that they can take informed decision in the future regarding the prescription of the drugs they receive. So that is all from our end. So thank you so much.